Okay, MonsterBots, my take on the BristleBot activity. I have a robotics club called the STEAM Team, and this lesson will be implemented with 6th through 8th graders and satisfies the following Massachusetts standards. The STEAM Team challenge for October is to make a simple robot that can move through a maze made out of cardboard. Even though its motion is random, can the BristleBot eventually find its way out of the maze? And on the right, I have some examples from Science Buddies. Here's a list of the materials we had available to the students. Okay, we had a coin cell battery, a vibration motor, construction paper, bottle caps, plastic straws, pipe cleaners, a small piece of double-sided foam tape, scissors, paper clips, googly eyes, masking tape, and popsicle sticks. This is a short video that I showed the students so we were all on the same page with installing the motor. Thank you, Left Brain Crafts. Next, we took a moment to talk about why the design notebook is important. A design notebook is a way for a designer or engineer to keep a history of his or her design projects from start to finish. It's a place to record research, observations, ideas, drawings, comments, and questions during the design process. Step 1, brainstorm and prototype. Students were encouraged to brainstorm with the people in their group using the engineering and design process worksheet. They were charged with designing an original bot using the list of available materials on the board, and then they were asked to list why that material is important for their design. They were then asked to create procedural steps to build the bot, and then asked why that design was going to be effective for meeting the goal of the challenge. Once prototype 1 was approved by the teacher, they were asked to bring those worksheets with them to the materials station to collect their necessary supplies. And then they could start step 2, building. All of the monster bots will look a little different, but they all share one thing in common. They will all be powered using a watch battery and a small vibrating motor that will be fixed to the bot's body, whatever that may look like, using a double-sided piece of foam tape. Students were also asked to be sure that they close the circuit by keeping one wire on one side of the battery, the positive, and the other wire on the opposite side of the battery, the negative side. Okay, step 3. Once their bots were built, they were able to try their bot. They were encouraged to try a flat floor surface first to see how the bot moves, and then they were asked to test their prototype in the cardboard maze. How did it do? Students were then asked to reflect and go back to the drawing board to start revising their next prototype in the Prototype 2 graphic organizer. They were also asked to list all of the adjustments that they made from Prototype 1 to Prototype 2. Here are just a few examples of the prototypes that I built. I built 3. The first prototype was not very stable and had the motor mounted the long way. Prototype 2, I mounted the motor sideways, so it only spun in circles. And then prototype 3, I used 2 motors mounted sideways in opposing directions. That was the most stable out of all of my bots.
I'm from Philly, and my husband's from upstate New York, and we just thought it would be a really great idea to combine our company.
And video 1 wasn't working, but I'll give it an attempt. Oh, there it is. Notice how it had no stability.